All right, so for page 3, problem number 1, we know that, let's see, graph the functions without using a calculator. All right, so the first thing we want to check is the degree. Since each of these exponents of the x's are 1, then we just count the multiplicities of each of the factors. So 3 plus 2 plus 1 is 6. And we also know that the negative sign out there means that we have a negative leading coefficient, and that means that the end behavior is going to look like that. It's going to open down and down. We have a factor of x, which corresponds to a 0 of 0. Factor of x plus 3 corresponds to a 0, or an x-intercept of negative 3. And factor of x minus 4 means we have an x-intercept of 4. With a degree of 6, we know that the ends of the graph are going to go down like that, and the leading coefficient being negative. Ends of the graph are going to go together. The factor of x plus 3 has a 2, multiplicity of 2, which means if we're coming from below, from the left of this x-intercept, it's going to touch the x-axis at that x-intercept. At 0, 0 has an odd multiplicity, or a multiplicity of 1, so we're going to be down below, so we're going to come up through that x-axis, crossing with looking like a line. And then at the x-intercept of 4, multiplicity of 3 for that corresponding factor, we're already up here, so we're going to come down with a squiggly, and now all we have to do is connect those pieces. Right? It doesn't matter how high or low we go. Connect all those pieces, and we have our graph of our polynomial function. Now, for problem number 2, we do the same kind of a thing. First, we identify the degree. The degree is we count, add up the multiplicities, as long as each of these exponents of the x terms are each 1, then we just add up the multiplicities. 2 plus 3 plus 2 is 7. And the leading coefficient is positive, so we know that we're going to go up from left to right. A factor of x minus 1 means we have an x-intercept, or a 0 of 1. Factor of x plus 2 gives us an x-intercept of negative 2, and a factor of x minus 3 gives us an x-intercept of positive 3. And again, we know that the end behavior is going to look like that. As we approach our first x-intercept of negative 2, we know that it has a multiplicity of 3. That means that we're coming from down below, so we're going to go up and we're going to have a squiggly right there going through the x-axis at negative 2. The x-intercept of 1 has the x minus 1 factor has a multiplicity of 2, so we're already above the x-axis, so we're going to be coming down here like that. And then the x-intercept of 3, the factor of x minus 3 also has a multiplicity of 2, which means we're going to touch the x-axis. And as we move up, as we connect each of these pieces, we see we have a maximum up there, down there, and then it comes up through there like that. Right, so it's the only way to connect the dots and connect each of those pieces. Okay. And then problem number 3 on the third page, define the following function. So we just do the opposite of what we just did in problems 1 and 2. We see what the graph is, so we know that the degree is at least 3. We know it's odd at least, because the ends of the graph are going in opposite directions. We know that the a is positive, because the leading coefficient, or the end of the right side, goes up. So if it goes up from left to right, it's always a is going to be positive. Same with this one down here. We know that a is positive down here. We know the degree is even, so we can just focus on that. So we have an x-intercept of negative 1, which means we have a factor of x plus 1. X-intercept of 0 means we have a factor of x. And an x-intercept of 2 means we have a factor of x minus 2. Degree 3, 1, 2, 3, check, a is positive. We're done with that one. And then finally, problem number 4 on page 3. We have a factor, or we have an x-intercept of negative 1. So we have a factor of x plus 1. We have an x-intercept of 0, so we have a factor of x, but also notice that the behavior is the graph is touching the x-axis. Touching means that we're going to have an even degree, or an even power, even multiplicity for that factor. And then finally, this x-intercept of 2 means that we have a factor of x minus 2, but also notice the squiggly going through. That's going to be a 3 or a 5 or whatever. You can make it a 5. But most likely, 1, 2, 3, we have 3 turning points, so the degree can't be less than 4. But as we can see, we have a degree of 3 plus 2 plus 1 is 6. And that would correspond to an even degree. So that's all we would need to do for that one. And that's it.